Stephen Hawking's black hole information paradox has bedeviled scientists for half a century and led some to question the fundamental laws of physics. Now, scientists say they may have resolved the infamous problem by showing that black holes have a property known as quantum hair. If correct, this would mark a momentous advance in theoretical physics. So, let's talk about it. Welcome to Space World. In today's video, we are going to talk about whether Stephen Hawking's black hole paradox finally has a solution or not. So, if you want to know more about it, then stay with us until the end of the video. No matter what you do in the universe, its overall entropy always increases. Even when we put things in order, assembling a puzzle, cleaning our houses, even unboiling egg whites, only the local entropy of that isolated component of our system decreases. The energy that we have to expend to accomplish these feats increases the total entropy by a greater amount than the ordering process decreases it by, and as a result, entropy always goes up. From another equivalent perspective, the total amount of information in a physical system can only stay the same or increase. It can never go down. But for black holes, that doesn't appear to be the case. If you throw a book into a black hole, that book contains all sorts of information: the order of the pages, the text contained on them, the quantum properties of the particles making up the pages, and the cover, etc. That information goes into the black hole, adding to its mass energy. Much later, when the black hole decays via Hawking radiation, that energy comes back out, but the information is predicted to be totally random. The book's information has been erased. Despite a recent claim that the paradox has come to an end, it still remains very much unsolved. Here's the science of what's really going on. Every particle that exists in the universe has a certain amount of information inherent to it. Some of those properties are static, things like mass, charge, magnetic moment, etc. But other properties are dependent on the system that it's part of, as well as the history of its interactions. Things like its quantum entanglement properties, its spin and orbital angular momentum, and whether it's bound to other quantum particles. If we could know the exact microstate of a system, the quantum state of every particle included within it, we'd know everything that was knowable about it. Of course, in reality, that's not physically possible. We have properties that we do know and can measure, like the temperature of a gas, and then things we don't know, like the positions and momenta of every atom of that gas. Instead of thinking of entropy as a measure of disorder, which is misleading and incomplete, it's more accurate to think of entropy as the amount of missing information needed to determine your system's specific microstate. That definition of entropy is key to making sense of the idea of quantum information. Now, after decades of scratching their heads over this paradox, scientists have solved the 50-year-old black hole puzzle first proposed by Professor Stephen Hawking that once threatened Professor Stephen Hawking's understanding of the universe. Researchers have probably solved the famous myth of Professor Stephen Hawking of the abyss, a mystery that has puzzled scientists for nearly a century. Stephen Hawking left physics with the mystery of black holes, and now physicists think they have a solution. Ironically, the late Stephen Hawking left us one of his first works throughout the black hole, encouraging researchers to explore possible solutions for the best part of the century. This paradox has plagued scientists for some 50 years and has caused some to question the fundamental laws of physics. One result of Hawking's paradox was the contradiction of these two basic theories. The discovery may ultimately solve the mystery of the black hole information proposed in the 1970s by Stephen Hawking and may help to link the ideas of general relativity with quantum mechanics. The wormhole network could solve the basic puzzle first proposed by Stephen Hawking, but the mystery of the black hole information was unresolved. The complexity of black hole information compares quantum mechanics with conventional relation, in which, on the other hand, nothing can leave a black hole due to gravity. On the other hand, in quantum mechanics, there is radiation. The paradox of black hole information exists because, according to Hawking's statistics, some electromagnetic radiation does not contain any information about the food history of a particular black hole during its existence. So, quantum hair allows you to keep track of the details of their makeup, solving complexity. The so-called quantum hair is the answer to the problem according to 2 new studies. This is what is known as quantum hair, said Roberto Casadio, a professor of theoretical physics at the University of Bologna. The authors call it the quantum hair of gravity because their theory replaces the earlier concept of hairless theorem founded in the 1960s. In addition, recently scientists have claimed to have solved the mystery in part relying on black holes to have what they call gravity quantum hair. 2 new studies on problem solving entitled Quantum Hair and Black Hole Information and Quantum Hair from Gravity have been published in Physics Letters B and Physical Review Letters, respectively. In a follow-up paper published in the independent journal Physics Letter B, Professor Xavier Calmet of the University of Sussex School of Mathematics and Physical Sciences and Professor Stephen Shu of Michigan State University claimed that quantum hair solves the mystery of Professor Stephen Hawking's knowledge about dark holes. Furthermore, an international team of physicists, including a professor and a graduate student at the University of Sussex, are co-authors of 2 papers that can make a significant contribution to our understanding of black holes and claim to solve a problem that almost confuses scientists. In January of this year, Hawking issued a statement saying that Hawking's statistics were incorrect and that he had come up with a new theory that would allow people to understand information spaces. Later, at a conference, renowned physicist Stephen Hawking gave one of 2 answers. When he calculated that the black holes had to evaporate gradually, emitting what is now called Stephen Hawking's radiation, he also created a problem. Hawking's statistics showed that all black holes evaporate slowly, but the extracellular particles have no trace of the quantum information they contain. In doing so, the researchers showed that although the resulting black holes may be similar in control, size, and spin, their gravitational fields differ, leaving traces of quantum information in constructive stars. With a series of sensible steps on how gravitations might behave with a certain force, the team demonstrated a logical model of how information inside a black hole stays connected to its surroundings with its point of no return, similar to a small perturb of a black hole, the field hair of its dark hole. Now, we would not say we understand physics, as much has been learned in the past, except that there is no known mechanism for the formation of white holes. White holes have never been seen to exist, and white holes do not appear when the stars collapse. Even if one of the theories is correct, what comes out of the white hole is an explosion of power, not an investigation, and certainly not human. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.